Today we're going to learn about how to use reference angles to find exact values for angles in any of the other three quadrants. We'll start out with our just a refresher of what we need to know. SOHCAHTOA are opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. The relationships inside the magic hexagon, particularly our reciprocal relationships so far. We haven't really talked about the other ones yet. How to put things on the circle, how to make a quick sketch. You won't need something as formal as this. You'll see me start off with that, but I'll show you how the quick sketch should look. And then this whole idea of QRS, quadrant, reference angle, and sine. And the idea of that is to help you not forget about anything. By way of understanding, what we want to think about is when I ask you a question, I'm going to be asking you questions about angles that are not in quadrant 1. But as you see, these are all quadrant 1 angles. We'll be using these for reference only. The question will still be about the angles and where they originated. There'll still be questions about quadrant 2 or quadrant 3 or quadrant 4, but we're using all these angles that exist only in quadrant 1 just as a reference. Also, as far as understanding, we'll be asking you about quadrantal angles. Anytime we ask you about a quadrantal angle, you can go straight to your calculator. Your calculator will give you those sine, cosine, and tangent numbers for any of the quadrantal angles. And if you have to find reciprocal functions, you'll just get busy taking the reciprocals. Well, the reciprocal of 1 is 1. The reciprocal of -1 is -1. If you have a function that's 0 and you need to take its reciprocal of the function value, the reciprocal of 0 is undefined. If you have a function value that's undefined, and your calculator would tell you that, then the reciprocal of an undefined function value is equal to 0. And you can see that by looking at the two fractions there. So let's move on to some examples and how we're going to do these. You do need to pay attention to the instructions because depending on what you're asked for, you don't want to go too far with the problem. You want to make sure you go far enough. So we'll see two sets of instructions for each of these problems. My first problem says express cosine of 240 as a function of a positive acute angle. And then we'll find the exact value. So let's start by considering, I'm going to move that over a bit. We'll start by considering what this looks like on the circle, and I have to plot where that 240 would be in order for you to understand how this works. So we're at 0, we're going to 90, we're going past 180. Now 240 is going to be somewhere in between 180 and 270. And so what I want to do when I start the problem is create a quick sketch of what you're being asked. Cosine of 240, we're going to put a 240 squarely in quadrant 3, that's where it belongs. This is 180, and you'll probably want to label that x-axis for reference. If this is 180 and this is 240, we need to figure out how large this angle theta is in between. And that's just a matter of subtracting 240 minus 180. So now we know that theta is equal to 60 degrees. Well, what we just did is we found the reference angle that we're going to need. We're going to use a 60-degree reference angle. But we've got a couple of other things. Since we started in quadrant 3, we have to consider the sine in quadrant 3. Well, what do you mean the sine? We mean the sine of the cosine function. And by sine, we're talking about plus or minus. Well, all points in quadrant 3 are minus, comma, minus. I've got to wait for my pen to catch up. And because it didn't quite catch up the way it should have. Because that all points in quadrant 3 are minus minus, that means the cosine will be negative in quadrant 3. So our answer is going to have a negative with it. So that's the S part. That's going to be a negative. Okay, we can move on from there and come up to write our answer now. If we know that we're in quadrant 3, our answer is supposed to be negative. This says a function of a positive acute angle. That means that our answer is supposed to be a trig function. And that's the easy part. The trig function doesn't change. If it started out as cosine, it's still cosine. This S, or sine, told us that we need to use the negative because we're in quadrant 3. So we'll put a negative in front of that cosine. And the last part of our answer is going to be coming up with the reference angle. Cosine of 240 degrees, we're going to use the reference angle of 60 degrees. So that's a three-part answer in order to come up with the function of the positive acute angle. Well, this is positive and it is acute, and that's what positive acute means. This minus sign comes from the fact that we're talking about quadrant 3 cosines. All quadrant 3 cosines are negative, and this trig function doesn't change. When you start out with a cosine, you end up with a cosine. So that's the complete answer for part A. We'd circle that. But part B asks you to go on and find the exact value of cosine 240. Well, it's not difficult. You're almost there after you've done all that other work. You know that your answer is supposed to be negative, so we'll put a minus sign in front of that. And now to figure out what cosine of 60 degrees is, all we have to do is look at that reference table. So I'm going to bounce back to my reference table. I'm looking for cosine of 60 degrees. Cosine of 60 degrees is equal to 1/2. So I can go back to that screen and I can write my answer is negative 1/2. Remember, the positive or negative you decided in the S stage. The 60 degrees you decided in the reference angle stage. And then you can take your answer from there. So answer to part B, the exact value for cosine of 240 will be equal to negative 1/2. Now, sometimes your calculator will give you that number, more often not. And so you feel free to use the calculator as a check, but when you type in the calculator and you get an integer answer like that, then that's fine, you can use it. Oh, this isn't working the way I expected it to, but you could type that in, cosine of 240 degrees in your calculator. It'll give you a negative 1/2 for an answer. Let's take a look at our next example. Express tangent of 135 as a function of a positive acute angle. Well, let me begin by marking off the 135. We start at 0. We're going to go up to 90. We're going to go to, well, we don't have to go all the way to 180. We're going to stop about here. And so that means that we're in quadrant 2. We want to find our reference angle. Now, the reference angle will always be the piece in between where you stopped and the x-axis. We will never find reference angles touching the y-axis, always touching the x-axis. So here's my reference angle in here, that angle theta. That's what I need to figure out. Not difficult to do. We say 180 minus 135. Looks like my reference angle for this problem is 45 degrees. Since I'm in quadrant 2, I have to figure out the sign of the tangent function. Everything in quadrant 2 is a minus comma plus. So the tangent function, remember for tangent you combine the two signs. You put this number over this number. So the tangent in quadrant 2 is going to be a negative. So I'm going to finish part A by writing a function of a positive acute angle. It's going to be a negative result. The trig function I'm going to use is tangent. I'm waiting for my pen to catch up. Negative tangent, because the trig function never changes. And now we're going to put our reference angle in there. We said our reference angle is 45 degrees. Again, you're not responsible for completing this picture. What I should see on your paper is just a quick sketch that looks like this. 135 here, 180 here, show me the 45 degrees in there, and you'll be good to go. That shows you're in quadrant 2. It shows that you calculated the reference angle correctly. You really don't need all the rest of the unit circle and all that on there. Okay, now that we've answered part A, we have a function of a positive acute angle, and sometimes I may have you stop there. I might not ask you to go on and find the exact value. So read the instructions. If you didn't have to go on and find the exact value, you'd want to circle this as an answer. You wouldn't want to circle the actual number as an answer. But in this case, part B says find the exact value. So let's take what we found in part A. We know our answer should be negative. We're going to ask ourselves what the tangent of 45 degrees is. You can look that up in your special angle table. The answer is 1, so you'd circle minus 1 if your question was part B. One more example. Secant of 330 as a function of a positive acute angle. We're going to start out the same way. We know we have a secant function, so we might be using our magic hexagon here. We didn't need it in the last two problems. Let's start at 0 and we go up to 90, 180, 270, and so 330 is going to be somewhere in the fourth quadrant. What you'll show on your paper is a sketch of that 330 degree angle in the fourth quadrant. We'll mark that 330. This one is 360. It's 0, but it's also 360, and we'll use the 360 whenever we need to figure out what the angles are in quadrant 4. And so to get how large this angle is in between 330 and 360, you're just subtracting. So we know that this angle theta is equal to 30 degrees. Well, I just found my reference angle. It's 30 degrees in this case. I know I'm in quadrant 4, so I'd have to figure out whether this is supposed to be a plus or minus. Everything in quadrant 4 is a plus, comma, minus. Now I have to stop and be careful on this one because I don't have my basic sine, cosine, tangent. What I actually have is a secant function. The secant is going to share the same sign as the cosine, and you can see that by looking at your magic hexagon. If we go back to that magic hexagon, things you should know that you want to have as a reference. We go to secant down here. Through the middle, we're touching cosine. Those are reciprocal functions. So instead of memorizing signs for the secant, we're going to say, well, what sign would the cosine have had? If the cosine in quadrant 4, going back to my problem, if the cosine in quadrant 4 is positive, then the secant in quadrant 4 is positive. So I know that I'm supposed to end up with a positive answer. So again, in part A, I leave the trig function the way it is. I know that it's going to be positive. I know that I don't change the trig function, and my reference angle for this is 30 degrees. Well, part B gets a little bit more interesting. Part B, I know that my answer is still going to be positive, but I didn't memorize anything about secants. I did, however, memorize the cosine of 30 degrees. If the cosine of 30 degrees is, I'm going to take a look back at my table. That's why you don't want to have to recreate these all the time, because you want them easily accessible. If the cosine of 30 degrees is square root of 3 over 2, well, I need to take the reciprocal of that because I want the secant. So the reciprocal of square root of 3 over 2, you would be flipping that fraction over, 2 over square root of 3, and then you'd have to rationalize it. Square root of 3 comes to the top, plain old 3 on the bottom. So your answer for part B becomes 2 square root of 3 over 3. It's a positive number. If you didn't have the sign there, you'd be okay, but I'm going to encourage you to always put the plus and minus signs in there to help you remember that you have to do that.